Hello, welcome to this week two class of constraint and unconstrained optimization. So I'll get started in about 5 minutes. I'm just waiting for some people to join. Hi Kishan, so I'll just wait for a few more minutes and we'll then get started. Just waiting for a few more to join. Is my voice clear? And my video is on. Uh, Sorry, I cannot hear anyone. So is my voice clear and my video is clear as well, and my screen is like visible? Okay, great. Yeah, I'll just wait for 2 more minutes and we'll get started. Just waiting for a few more people to join. Okay, so since you two are already here, so I'd like to hear about your feedback on assignment two. I think there are a lot of doubts related to it. I think you guys must have noticed that few of the problems were, I think one problem was repeated and the other problem had the correct answer missing from the alternatives that were given. So yeah, I've noticed that. So first of all, I don't set this problems and I don't post the solutions as well. So it's all about like all everything is with the instructors of this course and the main TA of this course. So I can clear your doubts, and my role is up until that. So regarding the marking and all, I'm not responsible for that. So I think they will take care of it. So it's better just you keep posting these things on discussion forum and hope they will notice and take care of it. So yeah, that's all you can do, I guess. Okay, so I think I'll get started with today's content. So welcome to this week two TA session on constraint and unconstrained optimization course. So we are in the linear programming part of this course, and last week we noticed like we learned some uh, yeah, but the thing is that I'm also not in touch with the instructors. So that's the issue, right? So it's my role is just for clearing your doubts for assignment, and that's all. So I haven't even talked to them, and I don't even know them as well. So that's the thing. So it's only way that can be done is if you keep reminding them or post in the discussion forum. So that's the only thing I think that can be done for now. Yeah, so I think I'll continue. So last week it was just the basics that you have learned of linear programming and so on, like basic variables, non-basic variables, and those things. And I think also the simplex algorithm became method. Those things I didn't discuss in the previous session, but I think that has already been covered, and you have already solved the assignment problem and submitted it. So I think what how these sessions are going, I think it's in 1 week delay of the actual content of the course. So the week three problems, assignment problems, and I think that's due this Wednesday. So what I'll try to do is that first I'll discuss week two problems and whatever queries that you had, and then probably if I have time I'll go into not solving, but discussing some of the assignment three problems because you have to solve it in the next couple of days. So yeah, I hope there won't be any issues with assignment three. Hopefully the problems are correct, but I'll just go through it once today. Okay, so as I mentioned, so the topics of discussion today will be first I'll solve some of the assignment two problems that were like most critical and people had doubt related to those. And then briefly probably we'll solve some problems on simplex big M method, and two-phase method is something that is the content of week three, so that I think you have already learned, and also you need to solve the assignment problems related to it. I think it has some problems related to degeneracy and then sensitivity. I think it's not covered a lot in this week three content, but yeah, it's just the introductory part, and I'll briefly discuss about the week three assignment. Okay, so first of all, this week two assignment problem, the fourth problem, the issue with this one was that the options that were given, the correct one was missing from this. So, and also the solution that they have provided, it was wrong. So, yeah, again, I'm just repeating since I think one person joined just now. So it's that I don't post the solutions there, and I don't set the questions as well. And I'm not even in touch with the instructors. So the only way you can get the marking right is that by posting in the discussion forum and hope they will notice and reply to it. But yeah, if you have specific doubts related to the problems, I can always like reply and get your doubts cleared. So that's my role uh, for the schools. Okay, so anyway, so let's move on to like solving this first problem. So what we have is this problem. Now I have to convert it in the standard form. So for that, what I can do is that, so let me write down this in the standard form. This 5x1 plus 3x2 plus x3 you will introduce, and it's equals to 30. Then you have 3x1 plus 6x2 and plus x4, that's equals 36. And then you have 2x1 plus 5x2, then plus x5 equals 20. And your x1, x2 up until x5 are greater than equals to 0, and this is maximization of 10x1 plus 20x2, and then other coefficients being 0. So it's 0 times x3 plus x4 plus x5. So now, if you construct the initial simplex tableau, it will look something like this. So let me write down the entire thing. So this is CB, this is B, this is XB, this is small b. Then you have x1, x2, x3, x4, and x5. And then you have the ratio, which is you can write it as xpr by yrj. So it's for the min ratio test. And also here you can write cj. And let's like populate the columns and everything here. So the Cj, these are your coefficients. So this is 10, this is 20, this is 0, this is 0, and this is 0, right? And initially x3, x4, and x5 will be in your bases. So what you will have is this is x3, this is x4, and this is x5. So you can write a3, a4, and a5 here, and the coefficients here are 0, 0, and 0. And the right hand side is given as 30, 36, 20. And let's complete this. So this is 5, this is 3, this is 1, this is 0 and 0. Then you have 3, 6, 0, 1, 0. And you have 2, 5, 0, 0, 1. So after this, you have to calculate your ZJ minus CJ. So this is here you can write. So this is nothing but you have to multiply this CB times this, suppose x1 plus CB, this one times this. Basically, you have to take this column and the column of x1, suppose, and then you have to subtract this CJ, whichever is written on top. So for this one, it's the multiplications are all zeros, so it's just, so ZCs are zeros, so that means that you are left with minus of CJ. Now you have to pick the most negative one, which is this one here. And for that, you have to calculate this, for this column, you have to calculate the min ratio. So this one is 30 by 3, this is 10. This one is 36 by 6, which is 6. And this is 20 by 5, which is 4. So that means your this one is your entering variable, which is x2, and your leaving variable is this one, this x5. So here this becomes your pivot. So you have to make this element as 1 and other elements in the column to be 0. So let's do that transformation, and have to write the table again. So let me do that. Yeah, all of this, if I'm doing it in Excel or something, it's very easy to do the calculations and I can just copy paste the tables. But since anyway you are not using it, I'm doing it at least for this first problem like this. Maybe later, if it becomes too much of a work, I will switch to that. Okay, so this one is 10, 20, 0, 0, 0, and this one is fine. So this is 0, this is 0, so this is A3, A4, this is X3, X4, and here X2 will enter, right? So this will be A2, this is X2, this is 20. And your p values, now you have to divide. So let's look at the third row here in the previous table. So you have to make that element which was 5, you have to make it as 1. So you have to divide the entire row by 5. So let me do that. So this 20 by 5 becomes 4. This is become, this will become 2 by 5. This is 1, this is 0, this is 0, and this is 1 by 5. Now let's move on to the second row of this previous table. So what you have to do, you have to make this element which was previously as 6, that you have to make it as 0. So that means you can do, so the first transformation that I did here is, suppose R3 prime, it's nothing but R3 divided by 5. Now the second transformation that I can do is R2 prime, which is the updated row. So it's the previous one minus, you can make it as 5 by 6 times of R3. So sorry, I think it will be 6 by 5. Now, if you take this element 5 now, so previously this element was 6, so it's 6 minus 6 by 5 times 5, so that becomes 0. So we have to apply it to every element of that row. So the first one becomes it's 36 minus 6 by 5 times of 20 and so on. So let me calculate that. So it's 6 by 5 times of 20 becomes 24. So 36 minus 24, that's 12. Yeah, that's why I think it's easier to do it in Excel because now I have to do everything by hand. So now next one becomes as 3 minus 6 by 5 times 2. But yeah, anyway, let's complete it like this. It will be 3 by 5. So next one will be 0, obviously. And the one after that, so both of them were 0 in that case. So that remains as 0. Yeah, next one is 1 minus 6 by 5 times. So that will remain as 1. And the final one is 0 minus 6 by 5 times of 1. So that becomes minus 6 by 5. Yeah, so let's move on to the first row now. So let me erase this. So here what you will notice is that you have to make this element which was 3 here, you have to make it as 0. So the way you can do it is again very similar. So R1 minus 3 by 5 times of R3. So let's do that in that case. So this is the transformation that I'm looking at. Yeah, so the first one is 30 minus 3 by 5 times 20. So that will be 30 minus 12. So that will be 18. Yeah, I hope it's correct. Yeah, so the next one is 5 minus 3 by 5 times of 2. So let's quickly calculate this here. So it's 6 by 5. So that will be 19 by 5, I guess. Yeah, next one will be 0. So that's pretty straightforward. Yeah, the one after that will be 1 minus of the rest of the thing. So that remains as 1. Yeah, the one after that will remain as 0 because, yeah, both of them are 0. And the final one, it's again very similar. It's 0 minus 3 by 5 times of 1. So that's minus 3 by 5. Okay, so now let's again calculate the reduced cost or the value ZJ minus CJ that I'm saying. So let's do that. So this is also called as the reduced cost. So here now what you have to do is 0 times 19 by 5 plus 0 times 3 by 5 plus 20 times 2 by 5. So now you have extra 20 here. So that means you have to for your first part of this calculation you have to take this into account. So that will be 20 times 2 by 5 is 8 and 8 minus 10 is minus 2. Yeah, next one is 20 times 1 minus 20, so this is 0. Next one is 20 times 0, so this will remain as 0. Yeah, this remains as 0. And the last one is 20 times of 1 by 5 minus 0, so that's 4, right? So here you have only one element as negative, so that will become your entering variable. So x1 is your entering variable. Now you have to again calculate your this ratio, min ratio test. So that will give you 18 times 5 by 19. So this is 90 by 19. Yeah. Next one is 12 times 5 by 3, so that will be 20. And the last one is 4 times 5 by 2, that will be 10. So I think the minimum out of this will be this first one itself. So x3 will go out and x1 will come in now. And your pivot should become this element, right? So you have to make it as 1 and all the other elements in this column as 0. So I hope this will be the last step of this problem. So let me again write down this table. And this will be Cj. This remains the same. Now this will become as A1, this is A4, and this is A2, right? So this will be X1, X4, X2, this will be 0, this will be 10, this will be 20. And your now you have to first what you can do. So your R1 prime now becomes R1 times 5 by 19. So that will make it as 1. And that will give you this as 90 by 19. This one is 1. This one is 0. This one is 5 by 19. This one is 0. And this one will be minus 3 by 19. We also write this. Yeah, so next one, let's do it in a simpler way, I guess. So what you can do, you have already transformed your, you have already, this R1 prime is already with you. Now what you can do, you have to make it as 0. So R2 prime could be R2 minus, let's pick this R1 prime itself. Yeah, R1 prime times 5 by 3. So that will be R1 prime here will be 1. Is it 5 by 3? I think it will be 3 by 5. Just a minute. Yeah, so for this element it will be 1. So it's 3 by 5 minus 3 by 5 and it will vanish, right? Okay, so let's do that. So first one will be 12 minus 90 by 19 times 3 by 5. So it will be 18. Yeah, so 19 multiplied by 12. Okay, so that's a lot of calculations here. I think it will be 228 minus 54, right? So it will be around uh, 174 by 19 if I'm not wrong. Okay, if something is off, then I'll just switch to Excel and later we'll do this calculation and show it to you. But let's quickly try to solve it here, right? Okay, so the next one is 3 by 5 minus this 3 by 5. So this is 0. Yeah, after that it's 0. So let's erase this. Yeah, so after that it would be 0 minus R1 prime is, so that element is also 0, right? So this will be 0. So that's fine. After that it will be 0 minus 5 by 19 times 3 by 5. So that will be minus 3 by 19. Yeah, after that it will be 1 minus, so that element is 0, so everything remains as that. And finally it will be minus 6 by 5 minus, so this minus and minus becomes plus, so it's 3 by 19 times 3 by 5. So that will become 95. So 9 minus, so I have to multiply it by 19. So I think it will be, okay. So it will be minus 105 by 19. 5. It's minus 21 by 19. Yeah, I think it's okay. By 95. Okay, let's keep it this way. Yeah, next, the third one. So what you can do a similar approach. So it's R3 minus say R1 prime times 2 by 5, right? Yeah, so for the first one, it will be 4 minus 90 by 19 times 2 by 5. So it will be 36. 76 minus 36 by 19. So it will be 40 by 19. Yeah, next one will be 0. After that, it will be 1 minus of, uh, here it's 0, right? So that will remain as 1. The next one, it will be 0 minus of, okay, just quickly do this. 0 minus of 5 by 19 times 2 by 5. So it will be minus 2 by 19. Yeah, after that it will be x4 1. So this is 0, and here also it will be, so it was 0. So that will remain as 0. And finally, uh, what you will have is R3, which this one is 1 by 5 minus, or this becomes plus 3 by 19 times 2 by 5, right? So it's 95, and this is 19 plus 6. Hope that's correct. 25 by 95, so it's 5 by 19. Okay, so I think this should do. Now let's calculate this one. So for the first one, it's 10 minus of 10, so that's 0. For the second one is 20 minus of 20, so that's 0. For the third one, uh, I think it will be 10 into 5, so that's 50 by 19 minus 40 by 19, so this will be 10 by 19. Yeah, after that, this one is 0. And for the last one, it's I think 100 by 19 minus 30 by 19, so that will be 70 by 19. So here, all the reduced costs are positive, so you need not have any other entering variable or leaving variable here. And so what you have right now, it's a solution which gives you x1 is 90 by 19, x2 is 40 by 19, and x4 is something like 174 by 19. So now let's calculate the objective function for this. The objective function was 10x1 plus 20x2. So Z max is 10x1 plus 20x2. So that's 900 plus 800 in the numerator. So that's 1700 by 19. So this will be your correct answer. So I think this was the answer that someone mentioned. Let me check. I think it was somewhere around 89 point something if I have done it correctly. Just a minute. Yeah, so it's 89.47. So I think my calculations are correct here. Yeah, so yeah, it takes a lot of time. So one problem took around me, I think, more than 20 minutes. Yeah, so but yeah, it's very easy if you do these calculations directly on Excel and just uh, track the formulas, and automatically the row calculations will be done. So yeah, all the options that were given in this problem that were wrong, and this will be your correct answer. And the solution that was also posted was wrong, and this will be your correct solution for this problem. But yeah, as mentioned, I cannot do anything about marking because I'm not responsible for it. So yeah, let's hope that sir or ma'am or the main TA of the course replies to the the concerns that you have raised there in the discussion forum. Okay, so that's all about this fourth problem. So let's see what else were there. So I think there was other issues. So yeah, question 5 and problem 6 both were same, but the answers that were there in the, like, while evaluation it was different, right? So the main thing was that there was supposed to be a different problem 6, and I think if you have gone through the solution, uh, there was a different problem 6 there. So I think there was that's a mistake from their part as well, and you guys should get marks for problem 6 as well, those who have like selected the same option. But yeah, so let's hope that will be resolved quickly. So I'm not going into the details of it because the problem 5, I think you don't have any doubts related to it because it's pretty simple and I think you have already solved it. So now let's move on to the next problem, which is problem 7. So I think someone raised the issue last time, I think some 2, 3 days back, that they were not getting the answer that's given in the options. But that's not true. It should not happen like that because, and also the solution that have been posted there, I think that's fine as well for problem 7 because I think the main issue is that there the artificial variables were not introduced as such, but the problem structure is such that you don't even need artificial variables to solve this problem. But anyway, you should, if even if you solve it by two different approaches, you should get the same solution. And the issue, I mentioned that the answer should be like it's correct, but still I think someone mailed today and raised concern about this problem 7. But since it was raised, I think it's better to just show it, and by solving it in two different ways, that anyway the solution that you will be getting is the same. So let's do that. So let me write down the problem. Yeah, I hope it was for question 7. It's not for the other. 8 was fine, I guess. Okay, just a minute, I'll check. Yeah, so I think it's for problem 7. Correct. Let me just go through to that discussion. Hold on just a minute. Yeah. Yeah, they raised an issue about problem 7 as well. Okay, but let's solve it right now. Okay, so the problem is minimize z equals 4x1 plus 8x2 plus 3x3 subject to x1 plus x2, 2x1 plus x3, and whatever you have, right? Now, you have to solve this, and you have greater than equals to type constraint here. So the basic idea behind you have to do is now you have to create an initial basic feasible solution. And for that, if you introduce surplus variables, the technique that generally is followed is that you add another artificial variable and you make that artificial variable take the value whichever is in the right hand side, and then you proceed with the simplex tableau. And after that, your goal is to remove those artificial variables by putting high negative coefficients in the objective function so that naturally that gets removed from your problem. So let's do it in two ways. One of them I think was already posted in the solution, but let's quickly go over it because anyway, there was that issue of whether the correct answer is in the option or not. So now you have to convert it in the standard form. So for that, you have to take maximization, and it's max of minus z. So that means it's max of minus 4x1 minus 8x2 minus 3x3. So this becomes your objective function. And now you have to introduce a surplus variable. So this will become minus x4. So that's equals to 2. Right now, I have not added artificial variable, but I'll come to it, like why I haven't done so. This is minus of x5. This is 5, right? And suppose I have written x1, x2, x3, x4, x5 greater than equals to 0. Now, in your initial basic feasible solution, what we try to identify is some sort of an identity matrix that you can have. So that means if some variable is present in the first constraint, but it's not present in the second, and probably some other variable which is present in the second constraint, but is not present in the first. So those coefficients kind of can act as an identity matrix. So here if you can identify this x2 appears only in the first equation, but not in the second, and x3 appears in the second equation, but not in the first. So that means you can always set x2 equals to 2 and x3 equals to 5 as your starting solution or this initial basic feasible solution, and then you can proceed as you have always done in the simplex method. So you need not even have any artificial variable in this problem because the problem structure is like that, right? So let's quickly write down the simplex tableau so that it becomes more clearer. So let me quickly do this. So you have x1, x2, x3, x4 and x5, and this is xbr by this one was yrj, I think. Now whatever is so you have two equations, and the ones in the basis are x2 and x3 in your initial basic feasible solution. So this is your a2 and a3, and let me write down the cj values. So this is cj, and this is minus 4, minus 8, minus 3, 0 and 0. This becomes your x2 coefficient is minus 8, and for x3 the coefficient is minus 3. And the right hand side is 2, 5, and let's write down the entire thing. So this is 1, this is 1, this is 0, this is minus 1, this is 0. And for this one, this is 2, this is 0, this is 1, this is 0, and this is minus 1. Now, if you look at the simplex tableau and focus on this portion, you can notice that this is a 2 cross 2 identity matrix. So because of your problem structure being like this, so that's why you could have picked this as your initial, as in those can be in your initial basis. So it's like if you add some x6 and x7 in this problem, that will be kind of redundant and it will just introduce more calculations to this problem. It's not even necessary. So yeah, so I think the reason for choosing this as your base is now should be clear to you. So let's proceed and see if we are getting the solution. So let me write down this. So this will be minus 6 times minus 8 plus, sorry, minus 8 minus 6, so that's minus 14 plus 4, so this is minus 10. For this one, it will be minus 8, so this will be 0. This is minus 3, so this will be 0. This will be 8, so that's fine. For this one, I think it will be 3, right? I hope I have, oh, sorry, I have made a mistake here. I think it will be minus 6, minus 8. So this will be minus 10. And the rest of the things, I think it's fine, right? Yeah, so now what you can notice is that this will be your entering variable. And now you have to calculate the ratios and you have to pick the min ratio. So for the first one, it's 5 by 2 and sorry, for the second one. So this one is 2. So the minimum one is this one. So this, which is I think, so x1 will be entering into the basis and x2 will be leaving from the basis. And this becomes your pivot. And this is already 1, so you need not do anything to this row. But for the second row, what you have to do, you have to multiply the first row by 2 and then you have to subtract it. So the operation here will be R2 prime equals R2 minus 2 times R1. So let's quickly do that. And this will be your CJ. And so now x1 has entered the basis and x3 was already here. This is a1, this is a3, and for x1 it's minus 4, for x3 it's minus 3. Yeah, so the first row will remain as it is. And for the second one, you have to multiply. So this is 5 minus 4, so that's 1. This is 0. Next one is 0 minus of 2, so that's fine. This is 1. Sorry. So next one will be 0 minus of minus 2, so that's plus 2. And this will be minus 1. So let me again do similar calculations. So the first one will be 0. Next one will be minus 4 plus 6. So that will be yeah, minus 4 plus 6 minus of minus 8. So that's plus 8. So that's 10. For the third one, it will be 0. The next one is 4 minus of 6. So that will be minus 2, right? And for the last one, it will be 3. So again, x4 is the one which is having a negative value. So x4 should enter the basis. And let's calculate. So for this one, it's 2 by minus of 1, but we don't, we typically, or we need not take any minus values here. So this one is 1 by 2, so that this one will enter the basis. So x3 will leave and x4 will enter. So that's uh, pretty much it you have to do. So that means your pivot element becomes this one. So what you can do, you have to divide this entire row by 2. So now your R1 prime is nothing but R1 by 2. And your, sorry, it's your second row, right? So your second row And for the first row, what you can do, whatever you had R1, then you can just add R1 prime because this one will become 1 and 1 minus of 1 is 0. So let's quickly do that, and probably after this step we will get the final solution. Right. So this will be your Cj. Now, so x3 has left, x4 has entered. This is a1, a4, this is minus 4, and this is 0. Yeah, so let's divide everything, this one by 2. And now I just have to add this one to the first one. So that will be 2 plus half, 5 by 2. Then it will be 1 plus 0. So that's 1. Then it's 1 of this is 0. Then it's half plus 1. So that's 3 by 2. Now it's 1 plus 0. So that's 0. Oh, well, I think I've made one mistake. Half plus 2, 0 plus 1, minus 1 plus 1. So this should be half plus 0. Here I made the mistake. After that it's 1 plus minus 1, so that's 0. And this is minus half plus 0, so that's minus half. Yeah, so let's calculate the reduced costs. And for the first one, it's this is 0, and this will become 0, 0, so this will 8. Next one will be minus 2 plus 3, so that's 1. For the next one is 0, and this one is 0, this will remain as 0. And for the last one, it will become 2. So now every reduced cost is positive, so it need not enter, so nothing will enter now in the basis. So that's the stopping point of your simplex algorithm. So x1 is 5 by 2, x2 is 0, x3 is 0, and x4 is half. Probably I think I had introduced x5 as well, so that will be 0, right? So let's check this, whether the constraints are kind of satisfied or not. So it's this one is 5 by 2 minus half, so that's 2, that's fine. Next one is 5 by 2 and this is 5, so that's fine. Now, whatever your objective function had 4x1, right? So minimizing of that objective function. So z-min, it's 4x1 because all the other values are 0 and x4 doesn't appear in the objective function. So this is 10, right? So this is your solution, and I hope this was there in the option. Yeah, Z minus 10 and correct answer was D. So this is the way to approach it. Now, uh, do you still have any doubt related to this problem? If anyone has doubt, then I can solve it by introducing artificial variables, say A6 and A7, and can redo everything. That I think it's should be clear to you that that's not necessary to this problem. So any questions related to this problem, you can ask right now, whether it's clear or not. Is it clear to you? Yeah, I hope it should be clear, but since there were doubts, I'll just quickly write it. Yeah, alternate way. Now it should be uh, max of minus 4x1 minus 8x2 minus 3x3 x1 plus x2 minus x3 say plus a6 equals to 2 2x1 plus x3 minus this should be your x4. Oh, sorry. The previous one will be x4 and this will be x5. This is x5 plus a7 equals 5. x1 to x5 are all non-negative. a6 and a7, the artificial variables, are non-negative. Now we can always start with a6 equals to 2 and a7 equals to 5, right? But uh, then you have to do, what you have to do is that this one will be plus 0x4 plus 0x5 minus, so m is 6 minus m is 7, where m is a very large integer that you can put. Now, the issue is that picking a6 equals 2 and a7 equals 5, so that will be your initial basic feasible solution, but that's very equivalent to picking x2 equals 2 and x3 equals 5. So it's just more computations with 7 columns being involved and nothing else. That's not actually necessary. And you can remove those columns A6 and A7 from computation, I think, after only the first step. So I don't think there is a need to show everything, and it's difficult to even do it by hand. So yeah, if you have like spare time later, you can try it out on Excel and you should be getting the same solution by this method. And anyway, since it's a linear programming problem, you should just look at the problem and should understand that it will definitely have a solution. And you can always solve it by some solver. Some solvers may be available online, or even you can do it by Excel. So Excel has inbuilt feature of solver. So that if there's some time uh, towards the end of today's session, I'll show it to you. And then you can check for your correctness, whatever you have done, and then you can get the solution. And there is an option to select that you can solve the problem by simplex method, and you can just give it to your Excel solver and it will give you solutions directly. Uh, so just check those before you post your doubts there, because you are claiming that something is wrong, but that's not actually wrong. So that should not happen, right? So in that case, if you just keep on claiming that this is wrong, then the actual thing, which the two of the questions which are wrong, those will be unnoticed, right? Because you need to have your credibility about what you claim. So yeah, just be careful with that. Don't claim any extra things that are that's correct, but you are claiming it to be wrong. Okay, so with that, I think I'll move forward. I think there were a couple of issues. I think one more problem was there related to unique solution versus infinite solution. And people made a mistake in that problem as well. And since it is involving that greater than equals to constraint, so that you have to solve by big M method. So in today's class, I have already shown you the simplex method, but since now big M method it's kind of involved in that problem, so let me solve that problem so that it becomes clear. So it's question 9. So the problem was max of z 6x1 plus 4x2. Now this is subjected to 2x1 plus 3x2 less than equals 30. Next one is 3x1 plus 2x2 less than equals 24. Then what you have is x1 plus x2 greater than equals 3. x1 and x2 are non-negative. So yeah, let's solve this problem. So first you have to convert it into the standard form. So let me write down the standard form. So let's write it. Yeah, later on I'll put the extra things that should be there. For the first equation, I have to have slack, right? So x3 is not involved anywhere. So let's add x3. For the next one, 3x1 plus 2x2, you can add x4 here. So that's 24. In the third equation, what you can do, you have to subtract. So that's a surplus variable. And then you can add an artificial variable here. Since x1 and x2 are involved in other equation, you cannot just set something to x2, and it's not like you can do it for a small problem. You can always construct an easy basic feasible solution. But yeah, it's more convenient to do it in this way. So let's add artificial variable a6, and this is 3, and x1, x2 to x5, and also a6 are all non-negative. And so this should have more terms, so that's 0 times x3 plus 0 times x4 plus 0 times x5 minus m times a6. So that's the high penalty that you are putting into the objective function corresponding to the artificial variable. So now let's construct the tableau, simplex tableau. So let me write down, this is CB, BXB, this is B. So I have 6 variables now. So x1, x2, x3, x4, x5, and a6. This would be xbr by yrj. Here it should be cj. Now let me write down the 64000 minus m. So initial BFS is x3 equals 30, x4 equals 24, and a6 equals 3, right? So those are the ones that will be there. So x3, x4, and a6. Correspondingly, I can write a3, a4, and small a6. And this will be 0, 0, and minus n, right? Now let me write down this right hand side. And for the first one is 2, 3, 1, 0, 0, 0. For the next one is 3, 2, 0, 1, 0, 0. For the last one it's 1, 1, 0, 0, minus 1, 1. Now let's calculate the reduced cost. So here you can write. So this two are 0. So let's consider the third row itself. So it's minus m of n minus 6. The next one it's minus m minus 4. For the next one it is 0. Then the next one is also 0. Then you have plus m, and for the last one is minus n. So this is again 0. So the first one is the most negative one because you have minus 6 kind of compared to minus 4. So this will be in your this will be your entering variable. So let's calculate the ratios, and this will be 30 by 2, it's 15, right? So this one should be a leading variable, and your leading variable is the one which is your artificial variable, right? This one, it's leaving. So that's good news. And for that, uh, x1 is entering into the basis, and you can leave this column of a6 in the next calculations, right? So let's do that quickly. x1, x2, x3. So now what you have is x3, x4, and x1. This is a3, a4, a1. Your Cj values are 6, 4, 0, 0, 0. For x3 it's 0, for x4 it is 0, and for x1 it is 6. Now what you can do, so the first one is here it's 1 itself, so you need not do anything related to the third row, right? So this is 3, this is 1, this is 1, this is 0, 0, minus 1. For the second one, what you can do, you can multiply the third one by 2 and subtract it. So it's R2 prime is R2 minus 2 times of R1. So that should give you a value, uh, it's not 2, right? It's this column, x1 column. So that should be 3 times of R1. Okay, so let's do that. 24 minus 9, so that's 14. 3 minus 3, 0. 2 minus 3, so that's minus 1. So this is 0, this is 1. 0 minus of minus 3, so that's plus 3, right? Okay, so for the third, sorry, for the first row, oh sorry, this should be R3. I've written it wrongly. It should be R1 minus, now it's 2 times R3. So for the first one is 30 minus 6, so that's 24. This is 0. This is 3 minus 2 times of R3, so that's 1. So next one is 1, next one is 0, and the last one is 0 minus 2 times of minus 1, so that's 2. So let's do this. So again, you need to just look for the third row. So that's 6 times 1 minus 6, so that's 0. For the next one, it's 6 times of 1 minus 4, so that's 2. Next one is 0. Next one is 0. And finally, what you have is minus 6 there, right? So again, you will have this one as your entering variable. So let me just quickly check if I'm doing it correctly. Uh, so this is problem 9, I guess. Yeah, that's fine, I guess. Let's calculate this ratios. So this is 24 divided by 2, so that's 12. This is 15 divided by 3, so that's 5. And this one is 3 divided by minus 1. You anyway don't take it. Oh, sorry. So this one will be your leaving variable, which is x4, right? And this one will be your pivot. So you have to divide the second row by 3. So let me write it down again. This should be the final step of this problem. This is 6, this is 4, this is 0, this is 0, this is 0. Next is in the basis, you have x3, you have x5, so, and x1, and here the coefficients are 0, 0, and plus 6. So now let's complete. So this would be A3, A5, A1. And first complete the second row, just divide it by 3. So that will be 5, 0, minus 1 by 3, 0, 1 by 3, 1. Next, you can complete the third row just by adding the previous third row and whatever you have in the second row right now. So this will become 8. So that's 1. That's 1. 2 by 3. This is 0. This is 0 plus 1 by 3. This is minus 1. This is 0. And you can also complete the first row by multiplying. So let me write down this R1 minus 2 times R2 times. Yeah, so this will become 24 minus 2 times of 5. So that's 14. This one is 0 minus 2 times of 0. So that's 0. 1 minus 2 times minus 1 by 3. So that's 5 by 3. Then it's 1 minus 2 times of 0. So that's 1. Then you have 0 minus 2 times of 1 by 3. It's minus 2 by 3. Then you have 2 minus 2 times of 1. So that's 0. Yeah, I hope this is correct. Just a minute, I'll quickly check. Yeah, this should be correct. And now, again, you can calculate this is 0. Next one is 4 minus 4, that's 0. This is 0. This will become 2. And this will become 0. Right? So this is your final solution that you have got from this stage. And you can have the solution as x1 as 8, x2 as 0, x3 as 14, x4 as 0, and x5 as 5. This is your basic variable. So this is basic, this is basic, and this is basic. This is your non-basic variable. This is your non-basic variable. Right? So just a minute, I think. What was the objective? 6x1 plus 4x2. So, and it was a maximization problem. So this is 48. So this is fine. The objective function will be like this. But if you go to I think the second question of assignment 2, there the problem was there exists a unique optimal solution to an LP, which is given by maximize of say z equals cx, subjected to sum x equals b, and x greater than equals to 0. If it was written that the correct answer was that zj minus cj should be greater than 0 for all non-basic vectors, and zj minus cj should be 0 for all basic vectors in the final iteration, or rather it should be basic variables, but anyway, that's fine. But let me write down these things. So for this one, it is 0. For the next one, it is 0. For the third one, it is 0. It is 2. And this is 0. So here, if you notice, for all basic variables, this is basic, and this is basic. For all basic variables, right? At the final iteration. And this one, uh, this is not strictly greater than 0 for all, because this is non-basic, right? All non-basic variables, right? That means what you can do, you can let x2 enter the basis, and you can again calculate some sort of a min ratio, and you can have another solution from this final step itself. So there I think x3 probably, so that will be 42 by 5. Yeah, x3 will be leaving, and I think x1, x2, and x5 will be in your solution. So I think if you do one more step of this, so that means this can enter the basis, right? So, and again, you can calculate the ratios, which is 14 times 3 by 5, which is 42 by 5. This one is again negative, so you don't really care about it. And this is 12, right? So this one is minimum. So this will enter. Sorry, this will leave. So x3 will leave. And your pivot now becomes this one. You can again do one step of the simplex algorithm, and what you will be left with another solution containing x1, x2, x5 as your basic variables. And the reason being that for a non-basic variable, so it's suppose z2 minus c2 here is equals 0, right? So that means you can do that one more step, and you will get a solution of x1 equals 12 by 5 and x2 equals 42 by 5. So I'm not going into the details of how you get it, but the objective function, if we check it, it will also be 48 in that case. So 6 times 12 by 5 plus 4 times 42 by 5. So yeah, so that's fine. 72, yeah, so that's 240 by 5, that's 48, right? So this gives you again z max equals 48. In fact, there was a claim in the problem that in the solution that was posted, that if you take any combination of these two solutions, you will also get another kind of multiple solutions to this problem. So now let me write, suppose capital X1 is one solution, which is your 8 and 0. Capital X2 is another solution, which is your 12 by 5 and 42 by 5. Your objective function is 6x1 plus 4x2, right? So that's easy, right? So now let's do one thing. So from the first uh, from the first solution that you have, so it's nothing but 6, 4, and it's 8, 0. So that will be your z1. So z2 is 6, 4. So in matrix form, you can write it like this. Now the claim is that if you take any convex kind of combination of x1, capital X1 and x2, that will also be a solution to this problem. Here it's z1 and z2 are equal, right? So let's do this. Suppose I take lambda times x1 plus 1 minus uh, lambda times of x2. So if I write down, so it will be lambda times 8, 0 plus 1 minus lambda times 12 by 5, 42 by 5. So let's write down. So this will be 8 lambda 0 plus 12 by 5 minus 12 lambda by 5. This will be 42 by 5 minus 42 lambda by 5. So this will be 28 lambda by 5 plus 12 by 5. This will be minus 42 lambda by 5 plus 42 by 5. Now, lambda belongs to 0, 1. So if you put lambda value as 0, you get that point 12 by 5, 42 by 5. If you put lambda equals 1, then you get 8, 0 as your solution. And now lambda can be anything. It can be half, it can be 1 by 3. It is any real number between this 0 and 1. And now whether that's, if you put this back into solution, whether that will be the same solution, same objective or not. So let's calculate your Z3. So this is 6, 4. This is 28 lambda by 5 plus 12 by 5. So this is 42 lambda minus 42 lambda by 5 plus 42 by 5. So the first one, uh, you're multiplying with 6. So that will be 6 times 1. So this is 160 plus 72 by 5. Next one is 168 lambda by 5 minus 160. Sorry, that will be plus, right? Plus 168 by 5. Now you can notice this and this cancels out, and you are left with 240 by 5. So this is 48, which is equals Z1 equals Z2. And this is true for every lambda. For every lambda belongs to 0. So therefore, we have infinitely many solutions to this law. Okay, so I hope this should be clear to you now, because there was a query regarding it. I think few people got the answer as this kind of stopped there. They thought that everything is fine in the final simplex tableau. Uh, Everything is non-negative, reduced cost. So they thought they have got the solution and it's a unique solution, but that's not the case. You have to check for those reduced cost values, and then only you can comment on whether you have infinitely many solutions or you have a unique solution to the problem. So I think those were the most critical problems in assignment 2. And yeah, I hope your queries are answered now. So there were issues with 2 problems, so problem 4 and 6, and yeah, keep posting it in the discussion forum and hope that will be resolved soon. Okay, so I think assignment 2, this has covered the simplex method and big M method, and those I have already discussed in today's class in solving these problems as well. Yeah, and the rest of the problems were simple, and some of the questions are conceptual, like related to the big M method, or probably some related to this concept of unique solutions and so on. So I think, yeah, that's mostly about this week 2 content. So now I can go to the week 3 content, and I can get started with that, and with the rest of the 45 minutes or so I have in this class. And yeah, I won't be solving directly the assignment 3 problems, but I can solve similar problems to that. But yeah, before I start discussing that, uh, do you have any other questions? You can ask me right now. So, so this is done for today. Simplex is done. Big M is done. Yeah, next is, I think, two-phase method that I want to discuss. and the assignment tree problems, related problems. Okay, so yeah, I'll probably give you a couple of minutes, and if you have doubts, you can ask me right now. Have you started doing assignment tree? Did you notice any issues like this in assignment tree as well? You can tell me right now. Okay, so yeah, I hope you haven't faced any other issues doing assignment tree. So yeah, so let me do it in this way. So the two-phase method and everything I can discuss in the context of assignment tree problems. So let me take similar problems and yeah, go ahead. You have a question? Yeah. Yeah. Yeah, go ahead. Mhm. Yeah, so the thing is that I am not the official TA of this course. I'm just a PMRF TA. So my job is only to like clear your doubts and to solve similar to your assignment problems. I'm not even in touch with the instructors of the course just yet. So the questions that they set and the solutions that are posted are not made by me. So that's already made by them. So the best way forward will be you keep posting this in the discussion forum and hope sir, ma'am, or any other main TA of the course take notice of it and probably resolve this issue soon. Yeah, but if you have any specific doubts related to some questions and all, you can always post and I'll be there to answer in the discussion forum. But regarding marking and all, I don't know about it. Right? Yeah, yeah. Okay, so let me go ahead with assignment three problems. Yeah, so okay, so let's start. So I think the first problem is like some what is the coefficient of artificial variables in the auxiliary objective function of the phase two method or something. So that's conceptual question and you should be able to answer it. So let me quickly kind of discuss the basic of this phase two method or the two phase method, I think. Sorry, I didn't write it properly. So it should be two phase method. Now, this is only useful when you have auxiliary variables in your problem. So suppose I give you something like max of C transpose X. So I've written it in the factorized form, right? Subjected to AX greater than equals to B and X greater than equals 0. So in such kind of a situation, you have typically auxiliary variables introduced in your standard form. So to give an example, so suppose you have something like 2x1 plus 5x2 greater than equals 3. There could be another equation, say 3x1 plus 4x2 greater than equals 9. So now what you typically do in the begin method, it's plus 5x2, then you subtract, which is a surplus, and then you add an auxiliary variable, say 5 here, that's 3. And for this equation, you can write minus x4 plus a6 equals 9, right? So a5, a6 are called this auxiliary variables, uh, your x1 or x2 are your kind of main variables, the variables, original variables of the problem. So here, your x3 and x4 are your surplus variables. And you might be having another equation like this 5x1 plus 9x2 less than equals to say 20. So there you can add another variable, say x7. So this will become your slack variable, right? So x7 is your slack variable. So the difference between this, so big M method typically does is that it takes those auxiliary variables in in the objective function itself, and it introduces a high penalty. So that's minus m times a5 minus m times a6, like that they do. But yeah, there are a simpler method of doing it, or maybe not simpler is a word to call it. There's another way of doing it. It's the two-phase simplex method, where in the first phase you create an auxiliary objective function. So, sorry. So let me call it as z star, and it is 0 times the variables plus say 0 times all the surplus variables, 0 times all the slack variables. And the interesting part is this minus 1 times all these variables, auxiliary variables. And you maximize this function z star in the first phase. So that means, and that you do by the simplex method that you have, and with subject to the original constraints of the problem. So it's like you are checking for a feasibility. So you are getting a feasible point out of it, but the objective that you have is kind of different. So in this case, since you are trying to maximize it, it should reach a value 0 typically. But if it is not 0, then that means some of the auxiliary variables that you have are taking a positive value in the final simplex tableau. So that means you cannot eliminate those extra variables from your simplex tableau, and that means you have no solution to that problem. So that's kind of an easy check from first step. And once if you have eliminated that, it's very like similar to the rest of the part with the bigger method. It's also very similar. Like it's just two different ways of doing it. And then yeah, rest you can proceed with the same objective function that you have, the original objective function, and the rest of the things like it's simple calculations and all. So yeah, let's see if I can solve one problem related to this. But yeah, so I think it's pretty simple. And first two questions of your assignment three, I think it will be from here only. So if you have understood this part, you can answer it. The third one is also, yeah, I think third one also you can also answer it by just the concept of this auxiliary variables and this two-phase method. So yeah, first three are conceptual questions. Fourth one, I think it's one of those where it is asked. So I think if you go through the problems, it will ask you to solve a problem using two-phase method. So yeah, two-phase method, it's even if it is being asked to solve by two-phase method, it might happen that you don't need to use two-phase method in certain cases. So in Q4, it might happen that all of the constraints that I can notice. So if all constraints are of less than equals to type, then you don't have a phase one, right? And you do not have uh, phase one of the two-phase method. So that means this this becomes simplex algorithm, and you can apply to solve this problem. Yeah, so I think if you go through the problem, you will be able to understand this. And yeah, you have to solve it by the similar method that I have already shown in the class. Yeah, I think the fifth problem is somewhat interesting in the assignment 3, where you have both less than equals and greater than equals to type constraint. And there the two-phase method will come in handy and you can solve the problem. So let me see if I can solve it, or just I'll probably just go through like 10 problems and I'll start solving it. So yeah, you can while solving this say fifth uh, problem or any other problems, it might happen that you encounter say no solutions, no feasible BFS that you can get, or it might happen that you get to some unbounded solution. So typically it might happen that you have a entering variable, so that you have detected, but you cannot detect any leaving variable from the basis. So in that case, the solution will be unbounded, because if you are trying to maximize the value, probably you can go up until beyond like infinity, towards infinity you can go, and you can probably say increase one of the variable values to infinity and you can maximize your objective. So that's the idea. So you might encounter it in one of the problems, one of the 10 problems that's given. Then I think problem 6 and 7. So those are kind of again conceptual questions. So that's related to degeneracy. So let me quickly, yeah. So this is degeneracy. So degeneracy, I think if you have gone through the lecture, so there are two types of degeneracy. So one is type 1, and the other is type 2. So you might get again this conceptual questions related to it. So type 1 is kind of, suppose, so this is your basic variables. This is your non-basic variables. Suppose x1, x2 are basic and x3 x4 are non-basic. So this means x3 and x4 both are zeros, right? This means x1 and x2 are non-negative. So it might also happen that x1 is greater than 0, but x2 probably is still 0, even if it's in the basis. So that's one type of degeneracy. So that's type 1, right? Then type 2 is something else where you have an entering variable. Suppose you have, but min ratio test gives the same minimum ratio for more than one variable. So there, it's typically difficult to detect which one should be leaving the basis, and so that's one choice you have to make. And if you don't do it properly, so you can encounter an issue called cycling. So I think that was discussed in the class as well. So you have to avoid this. And I think some method was discussed in the class. What is the name? I think Charn's perturbation method. Yes, I think it was. So, so I hope you have gone through the lectures because this is all being discussed already. So using this, you can detect the leaving variable. And the typical way of, so this is for tie breaking. Okay, so typically what is seen is yi1 by yik, this ratio where yik is greater than 0, and also the minimum of the one that gives you the minimum ratio, pick that element. And if even if it's a tie, you go for further. So yi2 by yik, then so on, say yil by yik, and till there is a tie breaking that you can do. So that's how you can address this type 2 degeneracy, and also the typical trick is to rename some of the columns and then calculate this ratios, and after picking the leaving variable it's kind of similar to what you do in simplex method. And in type 1 degeneracy case, it doesn't really matter even if your basic variable takes a value of 0, you can proceed according to the same simplex method that you typically follow, right? So that's all about the most of the conceptual problems that you have in the assignment. And I think problems of 8, 9, and 10. Yeah, so I think I noticed that some problem might have multiple answers in the assignment tree, so be careful with that. I don't know how again the correctness will be checked and whether you can even select multiple options while answering those questions. So if you can select multiple options, so you have to select probably one or two of the problems. You just be careful with that, and uh, if you just select one of the correct answers and whether that is being considered as correct or not, I'm not pretty sure how the options will work here in one of the problems, I think. So that might be one issue that you face in this week's assignment. Yeah, so and the rest of the power portion, I think. Uh, yeah, so I think there is one problem related to type 1 degeneracy. There was something related to type 2 degeneracy in the assignment problem. And I think one problem related to this variables being unrestricted in sign. So this typically, suppose I tell you x1 and x2 are unrestricted. So it can be either positive or negative or 0. So what is typically done? So you write it in terms of the difference between two variables where all of these variables are greater than equals 0. So you might have to replace those in your objective function and make it a standard form, and then you can solve it, just like using simplex or two-phase method, depending on what type of constraints that you have. Okay, so sorry about that. So let me solve one problem related to the two-phase method and whatever portion I can cover. And let's see with how much time I have. If I can quickly show you one problem, how to solve it in Excel, that will be good. So let's do that in the last 20 minutes. Okay, so let me pick one problem. So which one is easy? Let's do that quickly. Okay, so suppose I give you tend to be very similar. Hmm, okay, so let me change it up a little bit. It should be, yeah. So let's maximize this function, and this is subjected to, suppose I give you x1 plus 6x2, sorry, equals 0. Then you can have 3x2 plus, say, x3 equals 2, and x1, x2, x3 greater than 0. So solve this problem. Right, two-phase method. So let me quickly show you the steps of doing it. So the first step, what you can do, you have to introduce auxiliary variables in this problem because it's an equality type problem and you have to do that. So let's A4 I introduce here, and here I introduce A5. Yeah, there are a lot of ways of doing it, this problem, because it's very evident that what will be the solution of this problem. We can just look at it and tell that this will be the solution or something. But anyway, let's follow the step-by-step method. So so now I write the auxiliary objective function, which I call it as z star, and this will be again 0 times x1, 0 times x2, 0 times x3, minus 1 times a4, because those are my auxiliary variables, and 1 times a5. Now phase 1. So let me, okay, just a minute. Yeah. So in the phase 1, let's do this. This is CB, this is B, this is XB, this is B, this is X1, X2, X3, A4, A5, XBR by YRG. So this is 0, this is 0, this is 0 again. So this is minus 1, this is minus 1, right? And whatever you have here is that in the first initial basic feasible solution will be A4 equals 0, A5 equals 2. So A4 and A5 will be here, and this is small a4, this is small a5, and this is nothing but -1 and -1. And the right hand sides are 0, 2. So I hope this is correct. This is 1, 6, 0, 1, 0. This is, sorry, this is 0. This is 0, 3, 1, 0, 1. Now similarly, so this was my CJ. So now this will be, let me write it here. So this one is -1, -0. So this is -1. This is -6, -3. So that's -9. This one is -1. Next one is -1 plus 1. So that's 0. And the final one is should be also 0, right? Because it's in the basis. The most negative one from here is this one. So you have to pick this and calculate the ratios. So this is 2 by 3 and this is 0 by 6. So this is 0. So you have to pick this one. So this one will be your pivot. So in the next step, let's quickly do that. Okay, so what happens here is that x2 will enter and a5 will remain. This is a2, a5, and you have to divide the first row by 6. So that's 0, 1 by 6, 1, 0, 1 by 6, 0. And what you can do, you divide the first row by 2 and subtract from the second row. So this one is 2, this one is minus half, this is 0, this is 1, this is minus half, this is 1. And again calculate the reduced cost. So now it's half. This one is 0 and 0, so that's 0. This is -1. This is half minus, so that's 3 by 2. This is -1 and +1, so this is 0. So one of them is again negative. So this will enter and let's calculate the ratios. So this remains as 2. And we have an issue here, right? It's 0 by 0. So how do you interpret it? So typically you don't take this kind of cases. Uh, so the negative cases are kind of avoided. Some number by 0 is infinity. So those are kind of things you avoid. And 0 by 0 it's kind of undefined. So this anyway you cannot. So let's not bother about it and just pick this one. And this one will be your leaving variable. So let's do that. So this will become, so x2 is now here, x3 has entered, this is a2, a3, this is 0, 0, and this one is my pivot, and this remains as it is because I have a 1 here and I have a 0 already here, right? So let me write down the entire thing again. Now let's calculate the reduced ones. So it will be 0, this will be 0, this will be 0, this will be 1, this will be 1. So all are kind of non-negative here. And you don't have your auxiliary variables involved here. So the maximum value of the z star here you have got is 0, right? So z star max, from here you have got it as 0, and the reduced cost of those auxiliary variables are positive here. So there is no such cases of extra kind of uh, multiple solutions are not being involved here. But yeah, all those multiple solutions are in terms of x1, x2, x3 because one of the non-basic variables is having a reduced cost of 0. But again, this is with respect to the uh, objective function, the auxiliary objective function. So you need not bother it. So now what you can do, you can have this in your basis and you can go for the phase 2, right? So your phase 2 will involve, uh, so let me write down. Yeah, you need not write those extra things that you have. But now we have to write the original objective coefficients. So that's 4, 5, and 2, right? Yeah, so this is 4, this is 5, and this is 2. And this is x2, x3. This is a2, a3. This becomes your 5 and 2. And you can write down the values that you already had here by 6, 0, 2 minus half, 0, 1. Now you can calculate your Cj minus Xj from here. Sorry, it's so the first one is 5 by 6 minus 1 minus 4. So this is minus 25 by 6, I guess. Yeah. Next one is 0, and the last one is also 0. So this will enter your basis, but you have to calculate the ratios, right? So for the first one it's 0, and for the next one it's negative. So this one should leave. So let me quickly finish the final step. 4, 5, and 2. And what you can do here is now x1 and x3 are involved. For x1 it's 4, for x3 it's 2. And what you have to do here, you have, this is your, sorry, not this one. This one is your pivot, so you have to multiply this by 6. So this is 0, sorry, this is 1, this is 1, this is 6, this is 0. And for the second equation, what you can do is, just a minute if I am done correctly or not. Yeah, yeah, for the next one, what you can do, you can divide the, sorry, you can multiply the first equation by 3 and add it up. So this is 2, this is 0, this is 3, and this is 1. So let's calculate the reduced costs now. This is 4 minus 4, 0. This is 24 plus 6, 30 minus 5, that's 25. And for the last one is 0. So this is optimal, right? And for x1 and x3, the reduced cost is 0, and for the other one, it's non-negative. So what you have from here is the final solution, which is x1 equals 0 and x3 equals 2. And your x2 was 0. And so x3 it's only 1, so that's having a value of 2. So if you can notice from this equations, since x1 and x2 are non-negative anyway, uh, and their sum, this some positive combinations, sum is 0, so that means x1 and x2 are forced to be 0. And when x2 is 0, that means your x3 is forced to be 2. So anyway, from just by looking at the equations, you can tell that x3 will be 2, but this is the formal way of solving it by this two-phase method when you have a equality type constraint or some greater than equals to type constraint. Okay, so that's mostly about this discussion of this assignment tree. I think you'll be able to solve it. So I have some 5 minutes. So let's see if I can quickly show you how to solve a linear programming problem in Simplex. Sorry, not Simplex, in Excel. So let me check if I can quickly do that, right? So yeah, so I have to unshare this one and go to the Excel sheet. Okay, so give me just a couple of minutes. I'll try to show you. Yeah, so yeah, so I'll share a different screen now. It's taking some time to open. Okay, so let me solve the same problem that I have solved just now. So it's a max of say 4x1. I think you can see my Excel, but I think I can zoom further. Uh, it's not letting me. Okay. Yeah, so I think it's a little bit better now. Yeah, 5x2. Yeah, I'll probably go some 2-3 minutes over time, but I think that's fine. X1 plus 6x2 equals 0. Then another 3x2 plus x3 equals 2. And x1, x2, x3 are non-negative. So that's the problem set up, and let's solve it. Oh, sorry. So let me write down the variables first. So variables x1, x2, x3. I initialize them to say 0, 0, 0. So this will be later changed accordingly. Then I have, let's write the objective function. So here it's objective. So I have to write a formula here. So that's 4 times this x1 plus 5 times x2 plus 6, 2 times x3, right? and I have to write constraints. So constraints, or I can, so I have two constraints, right? Let me write it here. So the constraints, so I probably name it as G1 and G2. So again, I have to write an expression here. So that's equals uh, x1, which is this, plus 6 times x2, right? And that has to be equals, sorry, that's the sense, that's equals, and the right hand side is 0. Again, I have to write an expression, so that's 3x2. Oh, sorry, that's, I have to write 3 times x2. So here is my x2 plus x3, right? So that's equals, oh, okay, that's equals to. So now I have to give this information to a solver. So for that, what you have to do, not by here. Okay, so I think it's in the data. You can find solver. So in data tab, you can go there and you can have solver. And if it's not there, you can always add some add-ins in Excel. So if you just search add-ins, then you can install solver if you have not installed already. So I'm not going into that detail. Probably I can show it in the next class. But let's quickly solve this problem. So the solver parameters, this will be open. The objective function, that part you have to select. So this one is your objective function here. Now you are maximizing this, so you can select max by changing the variable values. So you can select these three columns, which are your variables, and then you have to add your constraints. So let's add it. The first constraint is, so let's add, so this expression. So this you have to select as equal, and the right hand side is this. So this you have added. And the next one, this one, again you have to select as equal, and the right hand side, that's equals to, right? So now you can click OK. So these two are added. Now I am saying make unconstrained variables non-negative. So that means this x1, x2, x3, this part as non-negative. So that will be taken care of, right? So yeah, so that's fine. Next, what you do is select a solving method. So this method, it's, you have to select a simplex LP. So you can select, and now you can just click on solve. Uh, Objective cell. Okay, I think I made a mistake. Oh, sorry, this objective one. I think, yeah, sorry about that. So this has to be this F14. So otherwise, everything was fine. Now solve. Yeah, I can keep solver solution, answer report probably I want. You can also have some sensitivity reports and so on. But if you can click on OK now, yeah. Now you can notice that this x1 is 0, x2 is 0, and x3 has changed to 2, and your constraints are accordingly changed, and objective value is 4, so that's 2 times 2. And if you go to your answer report, that gives you final value as 4. This is your original initialization, and that's fine. And whether the constraint is binding or not, how much slack is there, everything, those kind of information you will get. And from this, you can get this x1 to be 0, x2 to be 0, and x3 to be 2. So you can always solve your LP problems in Excel, and the small LP problems you can just always check in Excel and verify whether you have solved it correctly or not. So yeah, so I hope this helps you in solving your assignment problems, because You can always solve it by hand, and you can always go back and check and whether you have done it correctly or not. But probably it wouldn't be allowed in exams, but yeah, it's a good starting point to check whether you're doing everything correctly or not. Okay, so yeah, it's already 3 past 5, so I'll just have, if you have any doubts, you can ask within the next 5 minutes or so, and otherwise I'll close the session for today. Yeah, so anyone has any doubts or any questions? Yeah, if you have any doubt, you can ask, otherwise you can leave the meeting. Okay, Suresh, do you have any doubt? Otherwise, you can leave the meeting. Anupam as well. Yeah. Anupam and Suresh, do you have any questions? Otherwise, you can leave. Okay. Okay, I'll close the session if you have no doubts. Yeah, thank you all. See you next week.